Hi students, so today we will be learning some basic exponent rules. We know that this is an exponent and this is the base of a number. So we're going to start a bit lower down your page, and that is just look at what happens when we try to execute these exercises and see at the rules that we arrive. So x squared can be written as x times x, and x to the power of 5 can similarly be written as the x multiplied by itself 5 times, and I'm just going to put a dot here instead of multiplication to be consistent. So look what happens. What ends up happening is we end up with 7 of these. So this leads us to our first rule, which is when you have a common base with the exponents, what you can do is you can just multiply them, because that's how many of them you have in total. Similarly with division, we're going to write it out, and when we have same terms on the top and the bottom, then we tend to cancel them. So that's what we're going to do right now. We have 2 x's that can be canceled, and what we end up with is 3 x's multiplied by each other, and so we end up with x to the 3. What's the conclusion? Well, you can see that when you've got, again, the same base with the exponents, then your exponential result will be the difference. So you're going to subtract the exponents when dividing the terms. The last one is what happens is when you have an exponent and it's taken to another exponent. Well, let's see. Well, this x squared is multiplied by itself 5 times. So that's what I'm going to do. And we know that each of these is going to yield 10 x's in total, right? That's what this is fully expanded. Well, writing it in a more condensed terms, I can say that what I have here is x to the power of 10. Let's look at the generalization then. Well, when you have a power inside of the bracket and an outside of a certain base, then what you're going to do is you're going to multiply it. Okay, so these are the 3 rules for today. We're just going to bring them into practice, and they are right here. So there's the same base, and m and n are added. When it's division, it's m minus n, they're subtracted, and when one is inside, one is outside, then they're multiplied. This right here means that if you have 2 terms to the power of m, do take each one to that power. And this right here also says that if this is in bracket, then that m will apply to the x and to the y. So with that, let's try some. And as always, I encourage you to pause and just try as many as you can on your own, because then you're switching your brain into a higher gear of being more engaged rather than just copying it down. Yeah. So we're not going to work these out. Remember, the goal of today is exponent rules, right? So if I have 3 fours here and 2 fours here, then using my addition rule, this is going to be my final answer. Okay. Similarly here, I have y to the m and y to the 2. Well, adding these exponents together, then what I'm going to have is the final result of this will be y to the m plus 2. Okay, it doesn't matter if one is a number or the base is a number, the rule just maintains the same. Okay, this we already know. This is just a simple subtraction, so this you should have x to the power of 4, and similarly to this, we are dividing the terms, and so by our rule of subtraction, the exponents, our result will be n minus 2. We're subtracting the exponents. Okay, take a look at question 5 versus question 6. Perhaps you see that the difference here is that here the 2 is included in the brackets, as opposed to here it's not. Here the power of 5 applies to the m only. Okay, so here our result is going to be 2, and then here we have our third rule of this multiplication. So this is going to be 2 m to the 5a, as opposed to here, there it is, more than one term in the bracket. This is going to be 2 to the 5, and then m to the 5a. Now 2 to the 5 we can actually evaluate. That's actually going to be 32. So 2 times 2 times 2 times 2 times 2. And then the m is just going to be to the power of 5a. That's what that looks like finished, okay? So notice the difference. Okay, this one, okay, here, these are just coefficients, just numbers. So 3 times 2 is going to be 6. And these ones are exponents, so x squared and x to the 5. So we're going to apply our addition rule, and our final answer is going to be x to the 7. Notice we did not add the 3 and the 2. Those are just numbers, and this is just multiplication. If you wanted to, you could actually rewrite this in a different order. So you can, for example, go 3 times 2 times x squared times x to the 5, right? The order in the multiplication doesn't matter. And so now hopefully it makes sense why that's a 6 and that's to the power of 7. Okay, last one. So similarly, if it's just coefficients, then just deal with them as coefficients, okay? So 24 divided by 15, we're not going to subtract it. These are numbers. So what are they both divisible by? They're both divisible by 3. Okay, so let's divide them by 3. And 24 divided by 3, that's going to be 8. And 15 divided by 3 is going to be 5. Okay, now this is t to the 6 and this is t to the 6. So by subtraction, that's going to be t to the 0. So those are just going to cancel. So we don't have any more t terms left. And r to the power of 4 to r to the power of 2 is going to be r squared. Okay, and that is what your finished result looks like, okay? So that's our first day of exponents, and I just want to point out to deal with these coefficients like quote-unquote normal numbers. Okay, see you soon.